On July 1st, 2025, astronomers around the world made an announcement that instantly captured the imagination of both scientists and the public alike. For only the third time in human history, a mysterious object from beyond our solar system had been spotted racing toward the sun. This was not just another comet or asteroid drifting along a familiar orbit. This was something different, something alien to our cosmic neighborhood. It was moving with an almost frightening speed of about 137,000 miles per hour, a velocity so extreme that it left no doubt it came from interstellar space. The discovery immediately brought back memories of the two previous interstellar visitors that had passed through in recent years. The first was the enigmatic Oumuamua in 2017, a cigar-shaped object that baffled astronomers with its unusual acceleration. Then in 2019, Comet 2I Borisov entered the stage, looking far more like a traditional comet, but still carrying the mystery of its distant origin. And now this new arrival labeled 3I Atlas, the third interstellar object ever detected, seemed ready to challenge our understanding yet again. At first, the discovery felt almost routine, at least by astronomical standards. Observers scanning the skies noticed a faint point of light that did not match the catalog of known stars or asteroids. Over the next few nights, as its position shifted dramatically against the background stars, it became clear that this was no ordinary solar system body. Its hyperbolic trajectory, the mathematical signature of something that came from outside, confirmed its interstellar origin. A wave of excitement rippled through observatories everywhere. But unlike the fearful headlines you might expect, no, this was not a planet killer. Scientists were quick to reassure the public that the object posed no threat to Earth. Its orbit would bring it safely through the asteroid belt, that vast region of space between Mars and Jupiter, without any chance of a collision. It was a cosmic passerby, a visitor just passing through. Yet, the reassurance did little to calm the growing fascination. If it wasn't dangerous, then what was it? And more importantly, what could it teach us? From the beginning, one thing stood out: its speed. At 137,000 miles per hour, 3I Atlas was moving faster than nearly anything else in the solar system. And like most comets, it was accelerating as it approached the sun, pulled inward by gravity and energized by solar heat. Predictions suggested that by late October, it would reach an astonishing 152,000 miles per hour. Numbers like these are difficult to imagine. At that velocity, you could circle the Earth in less than 10 minutes. For astronomers, it was a reminder of just how powerful and dynamic our universe truly is. The moment of discovery was also a moment of perspective. For billions of years, our solar system has been bombarded by cosmic visitors, asteroids, comets, and fragments of stars. But only in the last decade have we gained the technology sensitive enough to notice the rare interstellar objects among them. Before 2017, none had ever been detected. Now, within less than 10 years, we've seen three. Is this coincidence? Or are we witnessing a pattern that suggests our solar system is far less isolated than we once thought? When news of the discovery spread, telescopes across the globe quickly turned their gaze toward the new traveler. Astronomers scrambled to measure its brightness, its color, its motion. Amateur sky watchers joined in as well, eager to catch even the faintest glimpse of a cosmic messenger from another star. There was a sense of unity in the scientific community, a race not to conquer or compete, but to understand. Every observation, every pixel of data, carried the potential to reveal secrets from far beyond our sun. In many ways, the discovery of 3I Atlas was like opening a book to a new chapter in human curiosity. Each interstellar visitor is a chance to study materials formed in environments utterly different from our own. It is a piece of another solar system thrown across the galaxy and delivered to our doorstep. And just like the first two visitors, this one promised not only answers, but also deeper mysteries. Because almost immediately, strange behaviors began to emerge. Behaviors that scientists could not easily explain. But at that first moment, on that summer day in July, the excitement was pure. Astronomers knew they had found something extraordinary. A third interstellar object, a new puzzle to solve. A reminder that the universe is not a quiet, empty void, but a vast, restless ocean of motion and mystery. And as 3I Atlas sped toward the inner solar system, it carried with it the promise of revelations we could hardly imagine. To understand why astronomers were so intrigued by the arrival of 3I Atlas, we first need to step back and look at what we normally expect from comets. These icy wanderers are some of the oldest relics in the solar system, frozen time capsules left over from its earliest days. Most comets we know of come from two distant reservoirs, the Kuiper Belt, a ring of icy bodies just beyond Neptune, and the even more remote Oort cloud, a vast shell of frozen fragments surrounding the solar system like a bubble. When one of these objects is nudged from its distant orbit and begins to fall toward the sun, something predictable happens. As it gets closer, solar radiation warms its surface and the ice begins to vaporize. Gases and dust are released, creating a glowing coma around the nucleus and sometimes forming long tails that stretch millions of miles into space. This process is so reliable that astronomers can usually forecast how bright a comet will become based on its distance from the sun. In other words, comets tend to follow a smooth curve of brightening the closer they get, the more light they reflect and emit. The physics behind this are straightforward. A comet's nucleus is essentially a frozen mixture of water ice, carbon dioxide, ammonia, methane, and other volatile compounds. When exposed to sunlight, these ices sublimate directly into gas. As the pressure builds, jets of gas burst from cracks in the surface, carrying dust particles with them. Together, they form the glowing halo we see from Earth. The coma scatters sunlight in all directions, while the tails are pushed outward by solar wind and radiation pressure. It is a dance of light and dust, and though chaotic on the surface, the overall pattern is predictable. Take, for example, Comet Halley, the most famous of all. Every 76 years, it swings through the inner solar system, and each time, its appearance follows the same basic playbook: dim at first, brightening as it approaches perihelion, and then fading again as it retreats into the cold. Or consider Comet Shoemaker-Levy 9, which broke apart in 1994 before crashing spectacularly into Jupiter. Even in its destruction, scientists could explain its behavior through gravitational stress and tidal forces. In short, comets may be dramatic, but they are not mysterious. Their behavior can usually be traced to well-understood natural processes. Brightness, for instance, is one of the key indicators astronomers use to track and forecast comet activity. In astronomy, brightness is measured in magnitudes, with lower numbers indicating brighter objects. A comet might be discovered at 18th magnitude, extremely faint, visible only through powerful telescopes. As it approaches the sun, it brightens steadily, perhaps to 10th magnitude, and if it becomes spectacular, it might even reach naked eye visibility at 5th or 4th magnitude. This is the standard curve, a smooth transition explained by outgassing and dust production. Color is another typical signature. Many comets glow green as they approach the sun. This emerald hue is caused by dicarbon molecules, simple chains of carbon atoms that fluoresce under ultraviolet light. It's a well-known chemical fingerprint. When astronomers see a green comet, they know they are looking at ordinary chemistry in action, not something alien or unnatural. Even fragmentation, which might seem dramatic, is well understood. As a comet heats up, stresses build inside its icy nucleus. Sometimes the pressure becomes too great and pieces break off. This doesn't mean the comet is alive or intelligent, it simply means it's fragile. Cometary breakups have been observed dozens of times, each consistent with thermal and structural stress. This is why the case of 3I Atlas is so compelling. Because while most comets follow these established rules, this interstellar visitor has repeatedly defied them. Instead of brightening smoothly, it has flared unpredictably, jumping in brightness by entire magnitudes overnight. Instead of glowing with the green of dicarbon, it has displayed a strange chemical mix with no known source for its emerald light. Its surface appears to shine directly, without the usual cloud of gas and dust. By setting up the baseline of ordinary comet behavior, astronomers could immediately see that something was off. And that is the key. Science often works this way. You build models of what should happen, and when reality refuses to follow the model, you know you're on the edge of discovery. So before we dive deeper into the mysteries of 3I Atlas, remember the standard playbook: comets are icy relics that brighten smoothly, glow in familiar colors, and fragment in predictable ways. They are frozen messengers from the solar system's birth, behaving like old friends we've come to understand. But 3I Atlas, from the moment it appeared, it refused to play by these rules. And that's where the mystery truly begins. If comets have a rulebook, then 3I Atlas seems determined to tear it up page by page. From the very first weeks after its discovery, astronomers began noticing behaviors that simply didn't fit the standard patterns they had come to rely on. And the more they observed, the stranger the story became. The first anomaly was its light. Normally, a comet glows because sunlight reflects off the dust and gas surrounding it. The nucleus itself, the solid, icy core, remains hidden under that bright veil. But with 3I Atlas, the glow seemed to come directly from the surface. Telescopes detected a point-like brightness rather than the hazy aura of a typical cometary coma. It was as if the object itself was producing or reflecting light in a way unlike anything we had seen before. For some scientists, this raised a provocative question: was the object generating its own light? Then came the matter of color. At first, 3I Atlas appeared reddish, a shade not unusual for comets covered in organic-rich dust. But then, as it approached Mars and the asteroid belt, something dramatic happened. Its hue shifted suddenly and unexpectedly from red to green. Green comets are not unknown, but the cause is almost always the same dicarbon molecules fluorescing under ultraviolet light. Yet when astronomers pointed instruments at 3 Atlas, they found something baffling. The expected chemical signatures weren't there. No dicarbon. Instead, they saw an odd cocktail of carbon dioxide, nickel, and cyanogen. None of these substances are known to produce the vivid green glow now blazing from the comet's surface. This wasn't just unusual. It was unprecedented. Scientific community found itself in unfamiliar territory. The green color could not be explained by the chemistry they knew. If it wasn't dicarbon, then what was it? A new molecule never before observed in space? Or, as some more imaginative voices suggested, perhaps an artificial energy source cleverly disguised as natural chemistry. As if that weren't enough, the object's brightness began to behave erratically. Most comets brighten in a smooth curve as they approach the sun, but 3I Atlas flared in unpredictable bursts. At discovery, it was faint around 18th magnitude, barely visible even through powerful telescopes. But then, without warning, it jumped to 12th magnitude. That might not sound dramatic, but in astronomical terms, it was a massive leap. Each step down in magnitude represents a significant increase in brightness, and this object was leaping entire steps at once. Observers described it as outbursts, sudden releases of energy that didn't follow the expected pattern. It was as though the comet were pulsing, flashing in irregular beats. And then there was its trajectory. Most interstellar objects that we've observed, granted, there are only a few come in at odd angles, cutting across the plane of our solar system. That makes sense. Stars and their planets are oriented randomly in space, so visitors should approach from all directions. But 3I Atlas was different. Its path ran almost perfectly parallel to the solar system's plane, threading its way between planets as though it were deliberately navigating. It passed near Mars, swung through the asteroid belt, and yet seemed to avoid Earth with uncanny precision. To some, this looked less like a random cosmic coincidence and more like strategy. And perhaps the strangest part of all was its plan for perihelion, the point of closest approach to the sun. According to calculations, when it reached that moment in late October, the object would position itself directly behind the sun from Earth's perspective. In other words, it would vanish into the sun's glare, hidden from our instruments at the very moment when its behavior would be most interesting to study. If you wanted to conceal your actions from curious eyes on Earth, you couldn't design a better maneuver. Put all of these anomalies together: surface glow instead of a dust coma, a sudden shift in color without the expected chemistry, erratic jumps in brightness, a trajectory suspiciously aligned with the solar system's plane, and a hide-and-seek act behind the U. Sun and you begin to understand why 3I Atlas has so many scientists puzzled, and some even alarmed. For the cautious majority, the explanation is that we are simply seeing unfamiliar chemistry and physics at work. After all, this is only the third interstellar object we've ever observed. We can't assume they will behave like the comets we know. But for a bold minority, the anomalies point to something more. Something artificial. Perhaps, they argue, we are not watching a comet at all, but a disguised probe, a vessel designed to pass as natural while concealing its true purpose. Whatever the truth may be, one thing is clear: 3I Atlas is not like anything we've seen before. Each new observation deepens the mystery. Each new burst of brightness, each unexplained chemical signature, pushes us further from the comfort of known science and closer to the edge of speculation. And as the object continues its approach, the questions grow louder. What exactly is this interstellar traveler, and why is it here? Whenever something in the universe behaves strangely, science begins with the simplest question: could this still be natural? Before jumping to conclusions about aliens or technology, astronomers work through every possible explanation that fits within the laws of physics. And in the case of 3I Atlas, there are indeed several natural processes that might account for its bizarre behavior. The leading idea centers around something called an outburst. Comets, after all, are fragile things, dirty snowballs held together by little more than frozen gases and weak gravity. When they approach the sun, heat begins to seep into their nuclei, vaporizing pockets of volatile material buried beneath the surface. If those pockets suddenly rupture, the comet can brighten almost overnight, releasing massive amounts of gas and dust into space. These outbursts can make a faint comet flare into visibility, surprising both scientists and skywatchers. We've seen this before. Comet 17P Holmes, for instance, stunned observers in 2007 when it brightened by nearly a millionfold in just 42 hours, going from invisible to the naked eye to one of the brightest objects in the night sky. Astronomers explained it as a sudden venting of subsurface materials, essentially a cosmic pressure cooker exploding. Could 3I-8 be experiencing something similar? Its irregular jumps in brightness might simply be the result of buried gases venting in unpredictable bursts. Another natural explanation involves fragmentation. Cometary nuclei are not solid rocks. They are fragile, porous, and riddled with cracks. As internal pressure builds, entire chunks can break off, releasing even more material. When this happens, the parent comet often brightens dramatically, not because it's alive or powered by machines, but because it suddenly has more reflective dust surrounding it. Astronomers saw this with Comet Shoemaker Levy 9, which famously split into multiple fragments before slamming into Jupiter in 1994. Even comets closer to Earth, like Comet Ison in 2013, have been known to disintegrate as solar heating became too intense. The unusual green color, too, might not require exotic technology. While most green comets owe their glow to dicarbon molecules, 3I Atlas could simply contain an unknown or less common compound that fluoresces under solar radiation. Our catalog of cometary chemistry is limited, especially for objects from beyond our solar system. It's entirely possible that the interstellar regions where 3I Atlas formed produced molecular combinations unfamiliar to us. For example, cyanogen detected in its spectrum can fluoresce under certain conditions, though usually much weaker than what we're seeing. Perhaps this interstellar visitor has a chemistry cocktail unlike anything in our own backyard. Its trajectory, too, could have a natural explanation. Yes, it appears aligned almost perfectly with the plane of the solar system, and yes, it seems to bypass Earth while skimming near Mars. But coincidence is not the same as intent. With billions of stars and countless objects flying through the galaxy, some alignments will look uncanny by chance alone. From our perspective, the path may seem purposeful, but to the cosmos, it's just geometry and probability at work. Even the timing of its perihelion, when it slips behind the sun, could be a coincidence. Objects on hyperbolic trajectories are shaped by the precise angle at which they enter the solar system's gravity well. To end up hidden behind the sun is rare but not impossible. Just because the geometry hides it from Earth's telescopes doesn't mean it was designed that way. In fact, many astronomers caution against the temptation to interpret anomalies as evidence of intelligence. History is full of examples where strange cosmic behavior eventually found a natural explanation. Pulsars, for instance, were once nicknamed LGM for little green men because their steady radio pulses seemed too precise to be natural. We now know they are rapidly spinning neutron stars, the collapsed remnants of massive supernovae. What once looked like alien signals turned out to be extreme, but perfectly natural astrophysics. The same may be true of 3I Atlas. Its strange light, its unusual chemistry, its unpredictable flares, these could all be signs that interstellar objects are simply more diverse than we imagined. After all, this is only the third one we've ever studied. With such a small sample size, it's dangerous to assume what is normal. Maybe the real lesson here is that our expectations have been shaped by local comets, and interstellar visitors play by a different set of rules. Of course, that doesn't make 3I Atlas any less fascinating. In fact, it makes it more exciting. Because if its behavior can be explained by natural processes, that means we are learning something genuinely new about the universe, new chemistry, new physics, new possibilities for how planetary systems form around distant stars. Every unexplained flare and every strange spectrum is an opportunity to expand the boundaries of knowledge. So yes, there are plenty of natural explanations for what we're seeing. Outbursts, fragmentation, unfamiliar chemistry, geometric coincidences taken together. They may be enough to account for the anomalies. And if that's the case, then 3I Atlas is not evidence of alien life, but something equally valuable, a once-in-a-lifetime chance to study the diversity of the galaxy up close. But even as scientists work through these rational possibilities, the mystery lingers. Because for every natural explanation, there remains a detail that doesn't quite fit. And that leaves room, however small, for more provocative ideas. Science thrives on caution. Astronomers are trained to explore natural explanations first, to exhaust every possible physical process before daring to suggest something extraordinary. But sometimes an object comes along that is so unusual, so uncooperative with the rules of nature, that even the most serious scientists begin to whisper the unthinkable. Could 3I Atlas actually be artificial? It wouldn't be the first time such a question was asked. When the first interstellar visitor, Oumuamua, was spotted in 2017, its strange shape, lack of a visible coma, and unexpected acceleration sparked a controversial debate. One of the loudest voices was Harvard astronomer Avi Loeb, who argued that Oumuamua might not be a natural rock at all, but rather a fragment of alien technology, perhaps a solar sail drifting through interstellar space. His theory was met with skepticism, but it made headlines worldwide and ignited a cultural fascination. What if we really had just seen evidence of another civilization? Now, with 3I Atlas, some of the same questions are resurfacing. Once again, Avi Loeb has stepped forward with a bold proposal. In a widely shared article, he suggested that 3I Atlas could be a kind of mothership, an interstellar craft capable of releasing smaller probes as it passes through planetary systems. The sudden outbursts of brightness, in his view, might not be random natural events, but controlled releases, signals of technological activity hidden in plain sight. The idea might sound like science fiction, but consider the anomalies we've already seen. A surface that appears to glow directly without the expected cloud of dust. A sudden and unexplained shift in color from red to green. Chemical signatures that don't match the molecules normally responsible for such effects. A trajectory that threads the solar system with uncanny precision, bypassing Earth while positioning itself behind the sun at perihelion, as if deliberately avoiding detection. Each of these quirks could be explained by natural chance, but together they tempt the imagination. The green glow in particular has fueled speculation. Since no known molecules in the observed spectrum can account for it, some have proposed the radical possibility of an artificial power, source perhaps even a nuclear reactor or some exotic technology designed to mimic cometary behavior. If you were an advanced civilization sending probes across the galaxy, disguising them as comets would be a clever strategy. After all, comets are expected to flare, to fragment, to brighten unpredictably. Strange behavior would be dismissed as natural variability. In other words, the perfect camouflage. And then there's the matter of its path. Unlike previous interstellar visitors, 3I Atlas travels almost perfectly along the plane of the solar system, intersecting with the orbits of multiple planets. Coincidence, perhaps. But to those who favor the artificial hypothesis, it looks more like reconnaissance. A mothership sweeping through, checking in on potential worlds of interest. The fact that it passes near Mars but avoids Earth has raised eyebrows. Why not us? Is it curiosity about Mars or caution about humanity? Some even point to a chilling connection. The object's origin appears to trace back to the constellation Sagittarius, the very same region of the sky from which the famous WOW signal was detected in 1977. That mysterious burst of radio waves, lasting just 72 seconds, has never been fully explained. Decades later, to see an interstellar object emerge from the same direction feels to some like more than coincidence. Could 3I Atlas and the WOW signal be related? A message and a messenger, separated by nearly 50 years? Of course, mainstream scientists warn against getting carried away. Extraordinary claims require extraordinary evidence. And so far, nothing about 3I Atlas definitively proves it is anything more than a comet. Yet the whispers persist. Because the truth is, humanity has always wondered whether we are alone. Each anomaly, each unexplained detail, provides fertile ground for speculation. And when speculation aligns with our deepest hopes or fears, it takes on a life of its own. Even within cautious circles, there is acknowledgement that we should remain open-minded. After all, the discovery of 3 interstellar objects in less than a decade suggests we are just beginning to sample the diversity of the galaxy. If we expect surprises, we must also be prepared for possibilities that challenge our assumptions. As Avi Loeb has put it, if we always assume everything is natural, we may miss the chance to recognize the extraordinary. So, is 3I Atlas a comet unlike any we've seen before? Or is it a disguised machine? A cosmic visitor sent by intelligence beyond our world? The evidence remains circumstantial, but the questions are profound. And as the object hurtles closer to the sun, hidden behind its blinding glare, one thing is certain: the universe still holds secrets we have yet to imagine. Every mystery eventually reaches a turning point, a moment when speculation must give way to observation, when theories face the unforgiving test of reality. For 3i8less, that moment is rapidly approaching. On October 3rd, 2025, this interstellar traveler will make its closest pass to Mars. And for the first time in human history, we may be able to capture direct images of an object from another star system, not from Earth, but from the surface of a neighboring planet. The excitement surrounding this event is enormous. NASA's Mars Reconnaissance Orbiter, or MRO, carries the powerful HiRISE camera, a telescope orbiting Mars that has given us breathtaking images of the Martian landscape. HiRISE is capable of resolving features as small as 30 centimeters per pixel on the planet's surface. When turned outward toward space, it won't achieve that same precision, but it could still capture remarkable detail of 3i8less, down to around 30 kilometers per pixel. That may not sound like much, but in astronomical terms, it could reveal whether the object glows from its surface or whether its brightness is diffused by a surrounding cloud. It could even hint at whether the structure is smooth and solid or fractured and irregular. For scientists, the chance to use Mars as a second vantage point is unprecedented. Normally, our telescopes on Earth must contend with atmospheric distortion and limited viewing angles. But from Mars, instruments have a clear, unobstructed view of the cosmos. If HiRISE succeeds, it could provide humanity with its first close-up look at an interstellar visitor. Imagine seeing with our own eyes the surface of a body that formed around another star billions of years ago. And it won't just be MRO. Other spacecraft may have opportunities as well. NASA's Psyche mission, currently en route to the asteroid belt, could cross paths closely enough to observe 3i8less. ESA's JUICE probe, on its way to Jupiter's icy moons, might also be in position. Even telescopes closer to Earth, like the James Webb Space Telescope, will continue monitoring the object as long as it remains visible. Together, these instruments form a global and interplanetary network of eyes, all focused on one mysterious traveler. The stakes could not be higher. If 3i8less behaves like a normal comet, outgassing in predictable ways, we may finally confirm that its strange behavior has natural explanations. We might see jets of gas erupting from cracks, fragments breaking off, or dust clouds forming in familiar patterns. That would be exciting in itself, a window into the diversity of interstellar chemistry. But if it does something else, something we cannot explain, then the mystery deepens. If its brightness flares behind the sun and reemerges altered, if its surface appears too smooth, too geometric, or if fragments seem to maneuver independently, then the conversation will shift dramatically. October 3rd is not just a date on the calendar. It is a potential milestone for astronomy. For centuries, humans have wondered about life beyond Earth. For decades, we have scanned the skies for signals. And now an object that defies expectations is approaching one of our neighboring planets, offering us the chance to study it up close. The possibility that we could witness something extraordinary, even alien, is what fuels the anticipation. But there is also a sense of humility. Even the best cameras may only reveal hints, not definitive answers. A blurred image, a faint spectrum. Science often advances in small steps rather than giant leaps. Still, those steps matter. Each pixel captured by HiRISE, each spectral line recorded by Webb, is a piece of evidence in the greatest detective story of our time. There's also the possibility of missed opportunity. If the object fragments completely near perihelion, we may lose the chance to study it in detail. If its brightness drops too low behind the sun, we may be left with unanswered questions. But even that uncertainty adds to the drama. We are watching in real time as the universe writes a story we can't predict. And so astronomers wait. Instruments are calibrated, observation schedules are drawn up, and teams across NASA and ESA prepare for a moment they may only experience once in their careers. The world's eyes will turn toward Mars, and beyond Mars to a tiny point of light hurtling through the void. In that point lies the potential to reshape our understanding of the cosmos, or, at the very least, to remind us how little we truly know. The approaching moment of truth is almost here. October 3rd could pass quietly, the object behaving like any other comet. Or it could mark the day we realized that we are not alone in the galaxy. Either way, the countdown has begun. When we look back at the story of 3i8less, what stands out is not just its incredible speed, or its interstellar origin, but the deep sense of wonder it has stirred in us. In less than a decade, humanity has gone from never detecting a single interstellar object to watching a third one streak across our skies. Each time the questions have grown larger. Each time the mysteries have multiplied. And with 3i Atlas, those mysteries may be reaching their peak. Think of what we've seen so far. A comet whose surface glows directly, defying the expectation of a hazy coma. A cosmic traveler that shifts from red to green without the molecules that normally explain such a color. A body that brightens not smoothly, but in sudden, dramatic bursts, as though pulsing with energy. A trajectory that threads through the solar system with uncanny alignment, avoiding Earth yet approaching Mars and hiding itself behind the sun at its closest approach. To some, these are coincidences. To others, they are clues. Science has worked hard to provide natural explanations, outbursts of volatile gas, structural breakups, unknown molecules fluorescing under solar light. These are powerful ideas, and they remind us that nature is often more creative than we give it credit for. But even if all of these phenomena prove natural, the significance remains. We are witnessing processes never before seen, learning about materials forged in a different stellar nursery, and expanding our knowledge of what comets can be. That alone makes 3i Atlas one of the most important astronomical discoveries of our time. And yet, the bold hypothesis lingers in the background. The suggestion that perhaps, just perhaps, this is more than ice and rock. That it could be technology disguised as nature. That it could be a messenger from beyond. For some, this feels too far-fetched. For others, it feels like a possibility we cannot afford to ignore. After all, if alien civilizations do exist, they may not announce themselves with flashing lights in our skies. They may choose subtler methods, ways of moving unseen, hidden in the ordinary until we look closely enough to notice the extraordinary. This is why October 3rd matters so much. When 3i Atlas passes near Mars, when HiRISE and other instruments point their lenses toward it, we will gather evidence that could settle some of these debates or spark entirely new ones. It may be our best chance, perhaps for decades, to study an interstellar visitor up close. And whether the outcome is mundane or revolutionary, it will be history in the making. But beyond the science, 3i Atlas offers us something more personal. It reminds us that the universe is still alive with surprises. That even in an age of powerful telescopes, advanced simulations, and endless data, we can still be humbled by something as simple as a point of light in the night sky. It is a reminder that we are part of a cosmos far larger, stranger, and more dynamic than we can comprehend. So let me leave you with a question. What do you think 3i Atlas really is? A comet playing by rules we don't yet understand, or a probe from somewhere else? Cleverly disguised as ice and dust? Share your thoughts in the comments. We'd love to hear your perspective. If you enjoyed this exploration, don't forget to like the video and subscribe for more stories about the mysteries of the cosmos. Your curiosity is what drives channels like this. And the more voices join in, the more exciting the journey becomes. At the end of the day, the true power of 3i Atlas is not just in its mystery, but in the way it brings us together. Scientists, sky watchers, and ordinary people alike are united in asking the same timeless questions. Where did it come from? What is it made of? And could it mean we are not alone? Whether the answers turn out to be natural or extraordinary, the journey of discovery belongs to all of us. So keep watching the skies. Keep asking questions. And remember, sometimes the universe sends us a visitor, not just to test our science, but to awaken our sense of wonder.